Well, Mrs. Gregory, I'm looking at the test hints, and I realize it's been a year since I've looked at these test hints. And since we're doing this a
Good
little,
thing we know this stuff.
yeah, since we're doing this a little out of sequence, this ought to be fun to go through and
Right.
sort of preview everything the kids are going to be learning through the flipped portion of the classroom this week.
What we're trying to do with these videos as we can is get them posted for you so that you have the test hints available and can kind of watch it as you go through the chapter, because maybe that will help you focus in as well. So we are on the second half of the test hints. It actually says number 21 through 41 on your test hint sheet. Of course, when you get the test, it's going to say question number 1. So our first one would be, the hint says what the principal quantum number shows. We should probably recap that there are 4 quantum numbers.
There are indeed 4.
Jot those down.
There are 4 quantum numbers, and of course you remember them as N, L, M, and S. We write the L as a script L so it's not confused with a 1 or an I or something like that. N, remember, was the principal quantum number.
Principal quantum number.
L was referred to in a video clip you saw as the azimuthal quantum number, but we talked about it in class as the sublevel number.
Right, sublevel or orbital quantum number.
Orbital quantum number. The M is the magnetic quantum number, and if you rewind quickly to these little orbitals that we had sitting up here on the tray, the yellow post-it notes that we had hanging down there indicated which of the orbitals in a sublevel system that the electron actually was in. And then spin is which of the 2 electrons are in that orbital, whether you're an up arrow or a down arrow if you think about electron configuration.
Because we know they have to spin in opposite directions in order to be able to come together in those little tiny orbitals because the electrons are negative and they want to push each other apart. And if you grab that chart there, we have kind of looked at this chart in some of our practice. You've seen this in a color version in your book, on the notes, and on some of the simulations and links we have for you. And if you look at the boxes, there's a box for each one of these orbitals. We have 5 in the D, so these D-shaped orbitals. We have 3 P-shaped orbitals, 1 S-shaped orbital, and then 7 F-shaped orbitals. So this all kind of merges together. And we also know that you spent a lot of time in your biology classes with Mrs. Ledman and in your 9th grade science class with Mr. Tobel and Mr. Walton and learning this stuff, and you already came in pretty good with your understanding of it, so we're psyched about that. Sure. But anyhow, we kind of got off track.
Yeah.
The principal quantum number shows us what?
Shows us which energy level in the electron cloud the electron is on.
Right. So we do need to keep going back to our Bohr model.
Which is way too simple.
Way too simple.
But it's great for, introductory students like yourselves.
Right. And these rings represent energy levels. And this would be level 1, 2, 3, and so on.
4,
And that we designate, we refer to it by the symbol N, because sometimes we don't want to write out the number, we just need to, it's like a nickname almost. We need to just have an abbreviation, kind of using the initials.
So N is going to have values equal to 1, 2, 3, 4, 5, 6, 7,
Correct.
8.
Correct. And it's showing us the main energy level, or the distance related to the distance away from the nucleus that particular electron happens to be.
Right.
Okay? That's kind of a vocabulary question.
And number 22 on
Which
the
is number 2.
on the test are the shapes of the SPD and F orbitals. And if you rewind again, we knocked that out with our red and green styrofoam models. S is spherical, P is peanut, and D is double peanut, and F is like a flower.
Like a flower.
Yes.
So this question will be about perhaps one of those shapes.
Yeah.
Okay. Number 3, which is test hint number 23, how to find the maximum number of sublevels in any energy level. And that goes back to our diagram again, and unfortunately we only have this one in gray and white, so we're hoping it shows up a little bit on camera for you. But how many sublevels are within each energy level? What is really convenient about this is that the number of sublevels matches the energy level. So energy level 1 has one kind of sublevel, just the S. Energy level 2 has two kinds, the S and the P. Energy level 3 has three kinds, S, P, D. Energy level 4, four kinds, S, P, D, F. Energy level 5, five kinds, S, P, D, F, and some orbital that isn't defined yet because we don't have enough electrons for it. But it could be there as we start making more and more elements.
At this point, we're still stuck with a maximum of 4 different kinds of sublevels.
So if I said to you, Mr. Seston,
Yes.
in energy level 3, how many kinds of sublevels are there?
Energy level 3, there would be 3. You'd
Oh.
have S, P, D, and that's it.
Yeah, S, P, and D, those kinds. If we're asking you how many orbitals total, then you got to add up 1s plus 3 p's plus 5 d's, and that's a different question. And I know in years prior, my students have had a little bit of trouble on that. Like they missed a question that they actually really knew the concept because they didn't read what it was really asking. So,
Did I just do that?
huh?
Did you ask me orbitals or sublevels?
No, I asked you sublevels,
Oh,
and then
okay.
I went off on a
Yeah,
tangent because
You've got to read the question.
right.
Some of this vocab kind of runs together, it's a little blurry, and if the question asks orbitals, that's one question, that's
Yeah.
a different answer.
Right.
If the question asks sublevels, that's a totally different question, completely different answer.
And it could also ask how many electrons.
Yeah,
Okay,
again.
so next
So
one.
number 4, 24 on the sheet, the maximum number of a given type of orbital.
Oh, I guess we kind of just did that, didn't we?
Yeah, how many p orbitals are there in a p sublevel?
Right. In any energy level, we're going to have 3 p orbitals. They line up on the x, y, and z axis. And we're going to have how many d's?
5,
5 d's, 1 s, and
7 f's.
7 f's.
That's correct.
Okay, within any given energy level.
Yeah.
Alrighty, hint 25, which is test question 5. The maximum number of a given type of orbital, of the electrons in a given type of orbital.
Yeah. Let-
Okay.
Let's do that one again. The maximum number of electrons in a given orbital type.
Okay, so how many electrons can fit into any one orbital? We've talked about this for the entire week. You should have seen it in numerous resources. This is kind of a small space, and we refer to it like it's a room, but it's really not a room. But only 2 electrons can fit in there, whether it's an S or whether it's the orbital that lines up on the PZ axis, only 2 electrons. Or one of these Ds that looks like it has all these spaces, only 2 electrons in any one orbital
Of any kind.
of any kind.
Remember, there's a big difference between orbitals and sublevels.
Right.
You have to read the question.
Now, if we ask you, how many electrons are there in the 3p sublevel, which means
The P sublevel on the third
Third
energy
energy
level,
level.
the P sublevel has 3 different P orbitals.
right. And if we put 2 electrons in each one, 2, 4,
I get 6.
6.
Yeah.
Yeah, 6.
Okay, the way
Okay,
I
and
do
the-
it. My fingers work different.
Right. And the f orbital, since there's 7 of them, they would have room for 14 electrons. The s orbital, there's just 1 of it, it only has room for 2 electrons. And the d, since there's 5 of them, there could be 10 electrons.
Yes, these 3 questions that we just went over, students get these wrong not because they don't know.
Right.
It's because they didn't read. They have to slow down.
Slow down and read the question.
Good.
Absolutely. Okay,
That
so we
brings
were
us
on
to 26, number 6 on the test. How to find the maximum number of electrons